Hello and welcome. I'm Andreas. I work as a trainer and consultant primarily for C++. And I'm also the creator of C++ Insights. And this is also the tool I like to talk about in this series. In today's episode, I want to talk about type traits and how they work. So I'll give you a better understanding of what they are doing, because most of them are no magic. Only a few type traits in the standard library that use compiler intrinsics or compiler magic to get their information. I would say 99% of them don't do that. So let's look at a case where we can implement things ourselves. What I want to implement is a type trait that's also in the standard library. If we start looking at the bottom here, I want to implement a type trait that's called isPointer. So as I said, it's in the standard library, no need to implement it yourself, but we use that to peek behind the implementation and how things work. So we start by providing, I would say, a helper type, which is able to store a compile time value. My class template or struct template here is called integral constant, and what we can see here, it has a template head taking a class t as a type template parameter, and it takes a non-type template parameter of the same type t called v. The class template itself is called integral constant, and it comes with a single member which is static and constexpr of type t with the name value, which is initialized with v. Okay, so this is our integral constant. That's our helper type. And now in B here, I'm creating an alias template, true type and false type. And true type here points to integral constant of type bool and true, while false type points to integral constant of type bool and false. So now I have the two types available, true and false type. And it's nothing other than a shorter version of writing out the integral constant part. So this is the base. Now let's look at isPointer. I have in C here my template. It's a class template here, once again taking a class t with the name isPointer. And that one derives from false type, and it does nothing else. This is the case that comes into play once I use isPointer with something that's not a pointer. Now, in D here, we make things really work. We have another class template that's a specialization of isPointer here. So it comes with a template head, class T. The struct, of course, is also called isPointer. And now we can see here it's specialized for the case T star. So this is the specialization for a T pointer. And that one now derives from true type. And this is how most of your type traits work if they are value-based. So we are looking at something that provides a value, usually true or false. There are others that, well, modify types, but that's maybe for another episode. So if we have a type trait that gives us a value, then it's usually that we derive for all other cases from false type. And for the specific one we are looking for, we are deriving from true type. And thanks to specialization, or sometimes partial specialization, we can instruct the compiler that isPointer here, my specialization in line number 17, gets picked for all the pointers. Okay, so this is how the type traits work. And now, if I use it with my static assert of int star, I know, because I wrote it, that both isPointer versions derive from something that comes with a data member, a static data member value. So I know if I call isPointer here with int star, I can say colon value because that one exists. And I know that if it's not a pointer, so if I say isPointer for int, colon value also exists. But this time it returns me false. You can see this, so if we transform this here, and we can see I get an instantiation here for my integral constant for bool and false. So obviously my value member here becomes false. It's of type bool. And for integral constant true, of course, it gets set to true. Now here we can see C++ Insights removes the alias template. So is pointer here in fact removes from integral constant bool and false, because this is the catch-all case. And is pointer for int star here derives from integral constant bool and true. Now this was the int star version, and here we have the simple int version. So this is how type traits work. First of all, we ensure that we have for all versions, so for the good and for the bad case, a base class that provides the same data members with the same name, value. Second, we use usual template behavior that we can say we have a more specialized version, and we use that one to map it to true type or to true, and all other cases to false. So this is how type traits work. I think it's brilliant. The error messages aren't sometimes, but that we can with that query things at compile time, I think that really helps modifying types, getting information. So that's what type traits are for. I hope this helps you to understand a bit better what type traits do and how especially they work, and what are the mechanics behind them, making them able to do their work. That's it for today. Stay tuned for the next episode. Bye bye.